right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development 1100 Programming Fundamentals with C# class, I'm doing a series of videos based on the PowerPoint slides for our textbook, that being, as you see on your screen, Muroc C# 7th edition. And so far, I have gone through the first 4 chapters, which means I'm now at chapter 5. It's probably going to work out, looking at what's in the book, that I'll probably have 2 lectures for each chapter. I'm not positive with that, but we'll see. Okay, just so you're aware of that in advance. All right, so let's just get into it. As always, we start with our cover page, which is how to code control structures. So in this chapter, we're going to look at if statements, switch statements, while loops, do-while loops, and for loops. More than anything else, that's what this is about. We'll also talk about how to get out of these using break and continue statements. All right, there's a little bit in here about breakpoints, the locals window, etc., but later there'll be a whole chapter that'll be on debugging. So finally, a little more on block scope. So here's what are called our relational operators. So as I've done previously, I'm going to do this again, and that is I'm going to bring up Notepad, and this is what I used in the last chapter. So I'm going to bring this up again, and we'll keep this just what we have right here. I'm going to just do that and get rid of all the rest of this stuff. So I've got int x equals 7, int y equals 3. So let's talk about the kind of comparisons we can make. I can say if x equal y, and that's asking, does the value of x equal the value of y? Well, you know that it doesn't, because 7 does not equal 3. So in this case, it's going to be false. We can also say if x is not equal to y, to which we can say not, and that would be true. All right, the next thing we can come in here and say is, oops, let me just grab the whole thing here. X greater than y, and basically not does, how about is the value of x equal to the value of y? Is the value of x not equal to the value of y? And this will be is the value of x greater than the value of y? And you know 7 is greater than 3, so it's true. How about less than? So is the value of x less than? It's not, so that's going to end up being false. Finally, the last 2 that are in here are greater than or equal to, and less than or equal to. So this first one is, I don't know what that is the value of x greater than or equal to the value of y? And again, true, but is the value of x less than or equal to the value of y? And that would be false. If you can understand that, you understand relational operators. There's really nothing more to say. You can check for equality. You can check for inequality. If one is greater than the other, if one is less than the other, if one is greater than or equal to the other, if one is less than or equal to the other. So those are our 6 relational operators. All right. Now they give examples in the book as well. If you like the examples in the book, go for it. All right. Here are our logical operators. Okay. And basically our logical operators allow us to combine things if we need to do or want to do that. Sorry about that. Okay, so let's take a look again. So we've got all this. I'll leave these here, but I'm going to comment them out for now. Let's put in a global or a multi-line comment there. So that would get all those out of there. So let's look and come into here. Okay, so I can say if x is greater than 5 and y is less than 2. Well, let's see. Is x greater than 5? Yes. So this part right here, this part is true. All right. Is y less than 2? No, it's not. So this part is false. Well, when you work with an and, both parts of your condition must be true. Since this is true and this is false, the expression is false. Now, let's contrast that with this. And that's an or. Is x greater than 5? Yes. The way that C# works, and it's the way a lot of programming languages work, is it does what's called short circuit evaluation. So as soon as this becomes true, since it's an or, meaning as long as either one of these is true, the whole thing's true, it never even tests that one. It doesn't have to. It's just true. Now, looking at these, and let me hit enter a few more times here. In fact, let me just remove these, because otherwise it's just going to be too much in the way. And let me grab these and copy them again. Now, with an and, if I say if x is less than 5, it's not. So the short circuit evaluation takes over again. Since this is false, it doesn't even have to check this. It's just automatically false. Now, if this had said if x is less than 5, meaning that that's false, since it's an or, it must check that side. Since that's false, and this is also false, now the expression is false. So with short circuit evaluation, it only tests as far as it has to make sure that something either meets the criteria or it doesn't meet the criteria. Now, what if I wanted to check both of them regardless? Then I only use a single one of these. Now it'll always check both sides. So even though this is true, it'll still check this. It'll find that it's false, and it'll go on anyway. And with this, even though that one's false, it'll check this. It'll find that's false, etc. So using just a single ampersand, which is and, or a single pipe sign, which is or, gets rid of the short circuiting. Usually you won't do that. You'll use the short circuiting because you only want something to happen if indeed the criteria you were looking for has been met. All right? Okay. So again, I'm giving you a little bit of a different spin, I guess, than what's in the book. Now, I've shown you these. The only one I didn't show you was not. So let's look at that one. All right, let's make a Boolean variable. And we're going to call it is married. And in my case, I am, so I set it to true. So if I do this, if I say if not is married, that is saying if is married is equal to false. It's the same kind of check as saying, whoops, this. In fact, I could write either one, but the second one is a much more verbose version. In the same way, you maybe have already figured this out, to say if is married is the same thing as saying if is married equal true. So the exclamation point is an inverter. It takes something that's true and makes it false. It takes something that's false and makes it true. All right? So now you can have very complex expressions that have a lot of this stuff in here. And let's put this back. Let's make these double again. Come on, Jeff. All right, so you can have a bunch of these. In other words, I can have ands and ors and nots all in the same expression. If you do that, you do the not expression first, then the and second, then the or third. Now, if you want to change that order, parentheses. But you automatically do your nots first. So if in other words, if I had this, if x greater than y, put in another paren here, and y is less than 3, or, I don't know, this may not even make sense, not z, something like that. This is going to do this one first because it's a not. Then it's going to do the and next, so it's going to and these two. Then it'll take the result of that and it'll or it with this. And if that confuses you, again, you're going to get plenty of examples of this as we go on in the semester. You're going to be doing this. All right? All right. Let's talk about if else, and then we'll go and do a switch. Okay? And I'm going to write, again, I'm going to write an example in here. I'm going to get rid of everything that I have there. And I'm going to do this. I'm going to say string, size, and I'm going to set it equal to S for small. Okay? So I can come in, and let's suppose we have small, we have medium, we have large, and we have extra large. All right, so I'm going to put another string in here, and it's going to be called your size. And I'm going to set it equal to the empty string. So I'm going to say here, if size equal S, your size, your size, come on, Jeff, your size equals small. And I'm going to put in here else. Some people put a space in between these, some don't, and run them together. Just be consistent, that's all. So else, and I'm going to have one last else at the end, else. Okay, so your size is small. If it's an M, your size is medium. If it's an L, your size is large. If it's XL, your size is extra large. And otherwise, we're just going to say, otherwise, we're just going to say, let's see, that's just was an XL. There we go. Otherwise, your size is unknown. Again, I'm trying to give you realistic type of examples, but that are still simplistic enough that if you understand this, there's not much more to it. So it's going to come in here. And since it's an S, it'll say, is it equal to S? Yes, it is. So it'll set your size to small, and it'll skip all of the rest. If it was an M, it'll say, is it S? No, it's not. So it'll skip this. Is it an M? It is. So it'll say your size is medium, and it'll skip this. If you come through and make this an L, it'll say, are you an S? Nope, it'll skip this. Are you an M? Nope, it'll skip this. Those will both be skipped. Is it an L? Yes. So it'll set your size to L, and it'll skip these. If you make this an XL, nope, 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 yes. So it'll set your size to extra large. Finally, let's just say you came in there and you put in something wrong, like a B. Not this, so it skips it. 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 So your size will be unknown. Now, if you can understand that, there is literally nothing more to this. If we left this else that you see here out and you had a B, all right, your size wouldn't be set to anything because none of the things would make sense. All right. Now, I'm going to go off to the side here. Now, just imagine that with what I'm showing you here, this was all that's here. But I want to show you another way to write this that you may find a little bit cleaner. All right. So I'm going to do it off to the side so you see this. So I'm going to say here, switch on size. All right. And then I'm going to come in here and say case S. Your size is small, and break. All right. So then I'm going to come down here. I want to make this so it's easy enough for you to read. It's going to be a little longer than the other one. M. Your size is medium, and break. Let's come down to here. Case L. Your size is large, and a break. Case XL. Oops. Your size, size equals extra large, and break. And finally, default. Your size is unknown, and you don't even need a break. Most people put it in, but you really don't even need it because you're down to the bottom anyway. Now, I'm going to make this smaller so it all fits on the screen. So I can make it a little bigger. There we go. So here is that whole thing done with if statements and else ifs. The else is never mandatory, never when you have else ifs. But if you have all these else ifs, and if the if is false and all the else ifs are false, and you leave out the else, nothing happens. All right? You can have just an if and an else. And if in that case, we wouldn't have had any of these else ifs. So if that's true, we do this. If it's not true, we would do this. Okay? This is done with a switch. Most people, even though you look at it and you go, well, there's more code, it's typically clearer to write it as a switch. So this is the word switch. This is the value I'm switching on. So it's size. Then I've got to do my different cases. Case S, which is the same thing as like saying if size equal S. So again, we set your size to small and we break, which means get out of here. If we don't put the word, let's say we left this break off and this break off and this one and this one. All right. If you leave off the break, even though it finds, yeah, that's true, it still goes down and does the next one and the next one and the next one, etc. So when you write a switch, you write a break at the end of each case, typically to get you out. All right, and this I noticed right here should have been just an M, not an MS. All right, so these will work exactly the same way. And if you have trouble or whatever, you can, always just bring this up and freeze the screen and take a look at it. I'm trying to give you more realistic type of examples. Now, if you remember earlier, we did that program with grades where we said if, and we said something like number grade is greater than 90. We did something like this. Letter grade equals A. Else if number grade greater than or equal to 80, that should have been an equal sign there too. Letter grade equal B. I'm not going to write the rest, but just imagine that I wrote the rest, please. All right. This you would not do in a case because then you'd have to write this. Case 90. Case 91. Case 92. Case 93. Case 94. Whoops. Case, yeah, and I'm doing it even though I'm wasting a little time here. Case 95. All right, I'm just going to write all these out. But hopefully you see, taking a quick look at this, why you wouldn't do this. Because with our grades program, we would end up having close to 100 of these things. Now I can come in here and say, letter grade equal A, break. That's a big waste of time. So when you're working with numeric ranges like this, and you've got big ranges, you don't use a switch. You'll use the ifs like we have here. All right. But if you've got what's the word I'm looking for? If you've got just a finite number of cases, it can be easier to read and understand by using a switch statement. Now, not everybody agrees with that. All right. And virtually anything that you write with a switch, as far as I know, you can write with an if. The reverse is not always going to be true, or you're going to end up writing so many cases that you wouldn't want to do that anyway. All right. You can have an if inside of an if. These are known as nested ifs. In other words, you only get into this if statement here if that's true. So if customer type is not an R, you go down to here. If customer type is an R, then you check the subtotal. If it's greater than or equal to 100, you give them a 20% discount. If it's an R and it's not greater than or equal to 100, you give them a 10% discount. Much of the stuff that's done in here is very common sense. And I think, at least, with a lot of this stuff, believe me, a lot of the stuff we'll do later in the semester is difficult. But with some of this stuff that's in here, people make it harder than I think it actually is. There's their switch example. Nothing at all wrong with it. Just like if you've got an if with else ifs and you don't need a final else, you don't need a default. Almost always you put one in. All right. And there's an example if it's an R or if it's a C, you will do this. All right. Now, there is something that has been added recently in here that's called a discard. You'll notice that they have rewritten this. All right, they have rewritten the if. I'm sorry, they have rewritten the switch. It looks a little bit different. This replaces the default. Now, like I said, this is fairly new. So using a switch expression with a discard, and there's other places where the discard can be used also. If you find that writing a little bit less code like that makes more sense, you can do that. And if you don't, then don't. Now, I don't know where you got with Mr. Gudmested last semester, those of you in the AWD1100 class, but this looks very similar to an arrow function, an equal sign followed by a greater than sign. Not going to go over that anymore right now. So here's some more examples of using that. There's one without the discard rather, and there's one with the discard. I'm not going to go into that any more than I just did. And more examples. Notice it's 9.0 and later. So in other words, this would not work in earlier versions of C#. All right, conditional expressions. These are kind of fun. They're known as the ternary operators. Let's go back to here. All right, now I'll come up to here and I'm going to do this. I'm going to have two numbers, int x equals 27, int y equals 34. And I'm going to have another int that's called max. Now, I think you could all do this by now. I could come in here and write if x is greater than or equal to y, max equals x, else max equals y. There's absolutely nothing wrong with writing like that, running it like that. It works just fine. There's no problem with it. But let's talk about how we can take these 1, 2, 3, 4, 5, 6 lines of code and write them as one line. I'm going to write this off to the side here. I'm going to say max equals x, I need my test, x greater than or equal to y, question mark x, colon, y. This is the ternary operator because it takes 1, 2, 3 different operands rather. Okay, and it has 2 operators. This is the true action, this is the false action. This says check to see if x is greater than or equal to y. If this is true, you do what comes after the question mark. If this is false, you do what comes after the colon. This can be a lifesaver because it really can make your code a lot shorter. It can also make your code, it can do what's called obfuscating your code. In other words, even though you might have less code, it might make it harder for people to read and understand. It is possible that inside of this, after the colon for the false action, you can have another question mark colon. Most people don't do that. All right? You never have to use this, but sometimes at least it can result in a lot less code. All right, and it's called the question mark colon operator or the ternary operator. It goes by different names. And here's their example. So if the subtotal is greater than or equal to 100, then you return 10%. Otherwise, you return 5%. There's a lot of different ways that this can be used. So they show it in here, and then they show how to rewrite it with an if. Okay? All right. So this is the enhanced invoice total form. Could we go back and write that? Well, we got a subtotal. All they're doing is they're adding the customer type and they're adding a subtotal. I don't feel like doing this one. We could, but let's see if there's a better one to do. But before we do that, let's talk loops. Okay, and we're going to do something that you're going to maybe laugh at, but I'm going to remove all of this stuff that I put in here so far, and I'm going to count to 10. That's all I'm going to do. I'm going to count to 10, and I'm going to print out the numbers from 1 to 10. So I'm going to come in here and say int x equals, let's put 0 in here. All right, and I'm going to type this in 3 ways. So I'm going to say while x is less than or equal to 10, and I'm going to basically, what do I want to do here? Let's make a string. So I'm going to say here string, and we'll call it output, and I'm going to set it equal to nothing. All right, so I'm going to put in here output plus equals x dot toString. Then I'm going to add 1 to x, and that'll be it. So the output of this is going to be, after I do this and I add this, x plus equal to string, let's see. The output is actually going to be now, it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is kind of hard to read, I think you'd agree. So output plus equal, I should be able to do this and say x dot toString plus a blank space. I think that'd work like that. There's other ways you can rewrite it as well. Now I'll get this. But what are we doing here? Well, the first thing to realize is this right here, x, is typically referred to as a loop control variable. In fact, usually I actually write this, I call it LCV for loop control variable. You don't have to do that. And that shouldn't have been XX, it should have been plus X. All right, so I'm going to make this LCV. Again, you do not have to do that. This is the one time it's considered okay to label these things or name them X or Y or whatever. All right, so that's the loop control variable. This is our loop control variable test, and this is changing the value of the loop control variable. So we come in here and it's 0. Is 0 less than or equal to 10? Sure it is. So we add the 0 to our output followed by a space. So we've now got that. Then we add 1 to LCV, making it 1. Is 1 less than or equal to 10? Sure it is. So we say output, so now we've got the 0 space 1 space. And we do this until we get up to 10. And we'd have another space here. So we have printed all that. Now LCV is 11. 11 is not less than or equal to 10, so it falls out of the loop. This is called a pretest loop because you check before you go into the body of the loop. If I had made this 11, 11 is not less than or equal to 10, all of this would have been skipped. So the output would have been blank. But this is typically referred to as a pretest loop, and it is called a pretest loop because you check everything before you get into the loop body. Now, this is as opposed to, I'm going to grab all of this and I'm going to make a post-test loop. It all looks the same so far, but I'm going to change this. This is the only time when you're using an if or a switch or a while or a for or a do while, you put a semicolon at the end. You must do that. Now, this is going to work the same way as what we just saw. Do this while this. The only difference is this is called a post-test loop. If this was 11, it's not checking it till it's already gone through. So it would output 11 and a space and then fall out of the loop. So again, the difference is the difference between the while loop and the do while loop is where are you doing the testing. And if you're doing the testing before you get into the body of the loop, it's a pretest or a while loop. If you're doing the testing after you've already gotten in and run the loop body once, that's a post test or a do while loop. The other one that's left is called a for loop. All right, now I'm going to make this a little smaller because I want all this to show on screen, but I will be able to do this in a minute. I don't need this anymore. And I'm just going to rewrite this. There we go. So that's everything. That down one, there we go. Now, what you should notice right away is the do while loop was 1, 2, 3, 4 lines of code. The while loop was 1, 2, 3, 4 lines of code. Really 6 if you add these two. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. The for loop is called a counting loop because you need to know in advance exactly how many times you're going through the loop. Here, even though we do know exactly how many times, we didn't necessarily have to. So if you've got an indeterminate number of things, like maybe you're checking how many customers you have and you don't know how many there are in advance, you cannot use a for loop. But you can use a while or a do while. This is another pretest. So if we set this equal to 11, 11 is not less than or equal to 10. And really all these i's I made in here again should be LCVs. That's the way I write it. Okay, again, you don't have to. It's totally fine to use, this is the only time it's considered acceptable to use things like IJK or whatever. Okay? So in a nutshell, what I've just shown you on the screen are the three basic types of loops. And again, the difference is in here, we are creating our loop control variable, we are testing our loop control variable, and we are changing our loop control variable. Here we're doing it in 1 line, 2 lines, 3 lines, 1 line, 2 lines, 3 lines. Here, 1 line, let me set that back again to 0. So 1 line, there's our creating, another one, there's our test, and another one, there's our change. If we forget to, like let's say we left this off. Let's just pretend for a second we left off that plus plus LCV. Now we get into an infinite loop condition. It'll write 0. It'll come up, 0 is less. It'll write 0 again, and again, and again, and again, and again. Almost always, you don't want it, what's called an infinite loop condition to occur. It usually means it was a mistake if you get an infinite loop. So I'll leave that up there for just a second for you to take a gander at, so to speak. But in our textbook, and I'm cutting up to 40 minutes again, so I want to finish this chapter up, and then I'll do another example. Here's the while loop. And again, are there examples better than mine? If you like theirs better, use theirs. There's the do while. There's the for loop. Now, let's quickly look at break and continue. All right. So if I were to have come in here, we didn't do this, but if we were to have come in here and said, if LCV equal 5 break. And I'm going to actually move this up to the top. Whoops. Like that. Then our output would be 0, 1, 2, 3, 4, and this wouldn't show. Break means get the heck out. Now, if instead of break, we put the word continue in there, then this would read 0, 1, 2, 3, 4, and it would skip 5, and it would go right to 6. So if we put a break in there, it would be 0, 1, 2, 3, 4, and that's all it would print. If we put a continue in there, it would be 0, 1, 2, 3, 4, 6, 7, 8, 9, 10. Again, this is all explained in your book, probably clearer than I'm explaining it right now. All right? All right, you can set breakpoints inside of loops. We will get into that in much more depth and breadth of coverage at a later time. I showed you the breakpoints before and how to set them. I showed you how to remove them. All right? There are different ways that you can step through your code, which is kind of neat. And I'll show you that when we write our next program. Okay? All right, this is a future value form. Let's write this one next. And here's our settings. Again, I'm not going to use theirs or their code. And this is, I don't like the factorial programs. This is a change one. Okay? And this is income tax owed. Let's see which one we're going to do here. Well, let's do the change one. It's kind of a fun program, so we'll do that one next. So I'm going to come back. That's the end of the chapter. That's it. So I'm going to go back and I'm going to grab this. And I will come back. In fact, this might be one that you actually are assigned. Tough. I'm going to do it anyway. So I'm going to come back and do that one in just a moment.